Hello everyone. So in this video, we'll be just exploring about integer exponents. Now integers, very well we all know what are integers. The negative and positive numbers are called as integers. But exponents also we are aware of. But what are these integer exponents? We'll be seeing in detail how to solve them and how do we simplify them. So to start with, just for a quick review, let's see what is an exponent. Exponent is a way to write repeated multiplication of the same number. For example, if you wanted to write 5 multiplied by 5 multiplied by 5 multiplied by 5, rather than writing all these fives, all the 4 fives, you can write it in exponent form as 5 to the power of 4, or the fourth power of 5, you can say it like that too. So even you multiply this, you will get 625. All what you need to keep in mind is this is not 5 multiplied by 4. It is not 5 multiplied by 4, which will give us 20. It is rather 5 multiplied by 5 multiplied by 5 multiplied by 5. So you have to be very careful when you are solving an exponent. Most of the students, the mistake which they do is they just multiply the exponent with the number. That is, for example, 3 multiply 6 is 18. No, this is not exponent, that is multiplication. Exponent is when the 3 has been written 6 times. So when you write the 3 6 times, you will have something like this. So rather than taking up all the space to write the 3's, we just write it in exponential form as this. 3 becomes the base because we are repeating 3, and then 6, how many times the 3 is repeated, becomes the exponent. So that's equal to 729. Similarly, here we have written 9 3 times, 1 2 3. So in exponential form, we write 9 as the base, the bigger number, and then 3 times we wrote 9. So 9 to the power of 3, or third power of 9. Okay, now that was all about exponents. Now just let's quickly revise the parts of a power. So this is called the base, the bigger number which we write. Like in the previous slide, we saw that we wrote 9 as the bigger number, which means 9 is the base, which is been multiplied how many times. And this number, how many times the base is multiplied, is called as the exponent. So this is the base and this is the exponent. You will find we will be using these words often in this lesson. So how do you read this? You read this as 2 to the 4th power. So there are many ways to read, 2 or 3 ways to read it. So here they have given you 2 to the 4th power. So you read the base first and then the exponent. Or you can say it as 2 to the power of 4. Even you can say that. Okay, now these already, we have an idea of all these parts of a power and all. So to explore further, let's look at this table. Okay, now in this table they have given the fourth power of 5, or you can say it as, so you can also say it as 5 to the 4th power, which means 5 has been multiplied 4 times. 5 multiplied by 5 multiplied by 5 multiplied by 5, which was given as 625, as we saw before. So here, what does this mean? This means 5 has been multiplied 3 times. Similarly, here, this means 5 has been multiplied 2 times, 5 multiplied by 5, and here 5 is just once, so that's why it equals 5. So all what you need to keep in mind is that do not ever multiply 5 with 4, because as you can see that there is a big difference. The common mistake students do is this: they just multiply the base with the exponent, which is completely wrong. So you have to be extra cautious when you are solving exponents. Okay, now similarly, 4 to the power of 4, also you have, which means 4 has been multiplied 4 times, that's 256. Or here 4 has been multiplied 3 times, which will give you 64. 4 has been multiplied 2 times, which will give you 16, or 4 alone. Any number to the power of 1 means it's the same number. Okay, now in this table there is a pattern. What is the pattern you can observe in this table? The more the power of the exponent, the more the value of the exponent, in fact, the number is bigger. the more now the exponents are becoming smaller, the value of the number is becoming smaller too, right? Here when the power was 4, it was 625. But when it became 3, it is 125. When it became 2, it's 25. It's logical, right? The more the number we multiply, the more the number becomes bigger. The less numbers we multiply, the answer becomes smaller. Okay. Now, what do you think will happen after this if there is a column with 5 to the power of 0? Because this is a pattern of most of the mathematical tables are based on patterns. So what do you think is going to be here? 5 to the power of 0. Any number to the power of 0, the value is going to be 1. Always remember, any number, whether it's a positive number or a negative number, if it is to the power of 0, as shown here, the value is going to be 1. So the base number doesn't matter. Okay, base number is, and it can be anything. It can be 2, it can be -5, it can be 2.5, any number. But if the exponent is 0, then the answer, the value of that is going to be 1. Okay, now what if further we analyze the value of exponents to be negative? So -1, 5 to the power of -1. So how are you going to solve this? Now, as you know, when the numbers are becoming smaller and smaller, they become in fraction form, or in this, they come in fraction form. So always remember, if the exponent is in negative, that means your answer needs to be in a fractional form because it is less than 1. Any number which is less than 1, of course, it's going to be in a fraction form with the numerator as 1. So any number with any base with the exponent as negative, you will have to write your answer in fractional form like this. But how are you going to write that in fractional form? Just see. Always remember, as I said, the negative exponent means your answer will be in fraction. So just put the fraction sign with 1 on top. And then just see, 5 to the power of 2 is going to be, 5 5s are going to give you 25. So 1 over 25. Once you write this in fraction form, forget about this negative sign here. You have already solved it. Okay, so 5 multiplied by 5 will give you 25. In fact, you need to write it down. 5 multiplied by 5 will give you 25. Okay, let's see some more. So 4 to the power of 0, as I told you before too, any number to the power of 0 is 1. Now anything in the exponent as negative, what is that going to be? Your answer will of course be in fractions. So as you can see, 1 over 4, because 1, the power of 1 is 4. So without the negative sign, the power of 4 to the power of 1 is 4. Okay, the next one here, again, it's a negative exponent. So which means 1 over 4 multiplied by 4. Now, what do you think? Without the negative sign, what is going to be 4 to the power of 2? 4 multiplied by 4 will give you 16. But because it is negative, so it is written in a fractional form. Hope this part is clear for you. So let's move on and see what are the other things we need to learn in this lesson. So these are the negative exponents. So you read this as 5 to the negative second power. 5, you read the base first, and then 5 to the negative second power. Okay, this is how you read it properly. Fine, let's see some examples here. Now 10 to the negative third power. Okay, the first step you need to write is 1, change it to a fraction, over 10 to the power of 3. Now remove the negative sign and just write the number with the exponent, because we already changed it to a fraction. So the the 10 comes down. So what does this mean? This means 10 has been multiplied 3 times. So which means 10 multiplied by 10 multiplied by 10, which will give you 1000. So the answer for this is going to be 1 over 1000. Next example, we have 2 to the power of negative 3, or 2 to the negative third power. So what are we going to do here? Always write the fraction, put 1 as the numerator, and then the denominator will be without the negative sign. So without the negative sign, it's going to be 2 to the power of 3. So 1 over 2 multiplied by 2 multiplied by 2, which is going to give you 1 over 8. So the value of 2 to the negative third power is going to be 1 over 8. Okay, let's move on and check some more different kinds of questions. Now, if you notice in the previous one, there are no parentheses around the base, right? So when there are no parentheses around the base, you have to solve the way I taught you now. Now, what happens when there is parenthesis around the base? Now, what do these parentheses say? That negative 3 is a number as a whole. So when negative 3 is inside the parenthesis, means you're going to multiply negative 3 according to the exponent. Anyhow, the answer is going to be fraction because the fraction exponent is in negative. So the steps are going to be the same. To you're going to write 1 as the numerator over negative 3 to the power of 4. So because negative 3 as a whole is inside the parenthesis, you need to multiply negative 3 4 times. So you have to be very clear here. Because the negative 3 is inside the parenthesis, you need to multiply negative 3 4 times. Whereas in the previous slide, we just multiplied 10 3 times or 2 3 times. But here, because the negative 3 is inside the parenthesis, we need to multiply negative 3 as a number 4 times. So what are you going to get if you multiply negative 3 4 times? Negative 3 multiplied by negative 3 will give you a positive 9. These are the algebraic rules. Then positive 3 multiplied by negative 3 will give you negative 27. Negative 27 multiplied by negative 3 will give you 81. It's a positive 81 because we are multiplying 4 negative numbers. So of course your answer, the final answer you're going to get is positive. It's going to be a positive 81. Okay, now keep that for a while aside. Let's look at the other example. Negative 2 to the power of negative 3, or negative 2 to the negative third power. Okay, again, negative 2 is inside the parenthesis, which means always the first step. Write 1 as the numerator, draw the line beneath, and then negative 2, because negative 2 is inside the parenthesis. So you're going to multiply negative 2 how many times? You're going to multiply negative 2 3 times. So that means negative 2 multiplied by negative 2 multiplied by negative 2. Okay, so negative 2 multiplied by negative 2 is going to give you a 4, a positive 4. When you multiply two negative numbers, your answer will be a positive one. So positive 4, then positive 4 multiplied by negative 2 is going to give you a negative 8 again, because you're multiplying a positive number with a negative one. So that's negative 8. Now, we do not ever write negative, only the negative sign with the concerned number. We give the negative sign as a common sign, and then we write 1 over 8. Now, if you notice the exponents here, it's 4 and 3. Okay, always remember, if the exponent is an even number, we know even numbers, 2, 4, 6, 8, even numbers. So if your exponent is an even number, your answer finally when you multiply, the one you're getting is going to be a positive one. Just this is a small trick or a tip, you can say. When the exponent is even, your answer will be positive, whereas when your exponent is odd numbered, your answer will be negative. So if your exponent was 3 or 5 or 7, your answer will be a negative one. But if your exponent is an even one, then your answer will be positive. There's a small tip for you. Okay. This is only the case if the number, that is if the base number is inside the parenthesis. If the base number is inside the parenthesis, then this tip you can use. Rather, if it was something like this, no, because they are already positive. So when you multiply, you're going to get a positive number. This is only if the base is inside the parenthesis. Hopefully this part also is clear for you. If it's not clear, you can just rewind a bit and then listen to the explanation again. Moving on, this is another kind of exponent where there are no parentheses. Okay, now we have seen the one with parentheses. We have seen with positive numbers also. just like that. The base is positive. Now we are going to see what happens when the base is negative and no parenthesis. Okay, one thing you need to remember is the base is negative and the exponent is negative. Definitely your answer is going to be a -1. Okay, always remember, if both of them are negative, your answer is going to be a -1 if there are no parentheses. If it's parentheses, the other one has to apply. But here, no parentheses, so your answer has to be a -1. The remaining steps remains the same. You write as a fraction 1 over 3 to the power of 4. So you multiply 3 times. Don't forget the negative sign because it's very important. 1 over 81. So -1 over 81. Let's see this example, -2 to the power of -5. So always put negative as common first, then 1 over 2 to the power of 5. Then you can write it without the negative sign because already we gave the negative sign as common here. So 1 over 2 multiply 2, 5 times, that will give you 1 over 32 negative. You just multiply them very carefully, so that will give you -1 over 32. Similarly, this one also, both of them have negatives, so answer is going to be -2. That's going to be 1 over 5 to the power of 2. This literally means both the negatives will get cancelled. That's why we are just choosing one negative and putting it as common. So that will give you -1 over 25. Nothing to get confused. Just write the tips or what the ways to solve each of them in separately in a book, in a notebook, so that it will be easy for you. You will remember it. Okay, now as we already know this, any non-zero number raised to the power of 0, any number with the power of 0 is equal to 1. So whether it's a decimal or a whole number or a fraction, anything to the power of 0 is going to be 1. Okay, now let's move on a bit and check how do we simplify expressions with 0 and negative exponents. Now in this situation, we are not going to solve anything. We are not going to solve anything. We are just going to simplify only. Okay, now you don't need to think what's the answer. There is no answer. Your answer will be in these forms because we are just simplifying them. Okay, how are you going to simplify this? This is k to the -4th power. How are you going to simplify? Just that they want you to write it in this form. That's all. So when you want to, just imagine that there's a number here. For example, 2. Okay. Now, if you have a 2, how are you going to write this in fraction form? 1 over 2 to the power of 4, just like how we did in these questions, right? The same one. Instead of 10, there in that question, it's k to the power of -4. So how did we write this? 1 over 10 to the power of 3. Same here. They did not give us the value for k, any number, so we just have to write it in this form. That's all. We are not going to solve it. We are just simplifying it. That's all. Okay, let's check what are we going to do with this. 3y to the -2nd power. So 3 means 3 and y to the -2nd power means 3 multiplied by y to the -2nd power. Okay, now only we have to write this in a fractional form. So when we write this in a fractional form, it will be 1 over y to the power of 2. Just like how we wrote this, we are going to only write the exponent in negative form, sorry, fractional form. Okay, so this means 3 multiply 1 will give you 3 over y to the power of 2. Simple as that. Only write the negative exponent as a fraction and then you can just solve how it is. Okay, let's see some more examples here. We have c d to the -2nd power. This means c multiplied by d to the -2nd power. So which one are we going to write in fractional form? Are we going to write c in fractional form or d in fractional form? Just imagine that they are numbers. That's all. Just think that they are numbers. Okay, so this is a separate term, this is a separate one. They both are separate, but there is no multiplication, so that's why they both are together. So we are going to write this in fractional form. So when we write in fraction form, how does that become? 1 over -2 to the power 1 over d to the power of 2. Okay, so that means c multiplied by 1 will give you c over d to the power of 2. It's easy if you just a little bit concentrate and try to understand. Okay, now moving to another question. We have 2 to the f to the power of 0, 7g to the power of -10. All right, now remember, if any number has the exponent as 0, what is the value of that going to be? It's going to be 1. We learned this. So just think, if there was a number here, the value of this number is going to be 1. So that's why in simplifying, we write 2 multiplied by 1. 2 is already there, multiply by 1. All right. Now, the remaining stays the same. This is the first step. Now, we have g to the negative 10th power in the denominator. Okay. Now, when you want to change or when you want to simplify, just bring it up. So g, now the negative one, when we wanted to make it positive, we wrote 1 over t, or 1 over the exponent. Now, what if the exponent itself is down? To make it positive, we need to move it up. That's all. So here that exponent is negative and it's down. So g to the negative 10th power. To make this a positive one, we just move it up. So that will become g to the 10th power and then over 7. How did this become 2? 2 multiplied by 1 is 2. Just move this 2 up and then 7 remains down. Okay, in the next one, just let me show you some tips and tricks how to solve, simplify these exponents. Okay, now, as you can see, 2, a to the power of negative 5, b to the power of negative 6. All right, now this is the tip. You can just call it a tip. It's a small useful thing which you can keep in mind. Okay, when you simplify, the negative which is up will move down. Okay, so remember, when you are simplifying, the negative exponent which is up moves down and the negative exponent which is down moves up. So your simplified expression is going to be 2 b to the power of 6 over a to the power of 5. I will repeat again. When you are simplifying, just move the negative exponent. If the negative exponent is up, move it down. If the negative exponent is down, move it up. Just do the opposite, that's all. Okay, keeping this trick in mind, let's solve another question. Now, which is the negative exponent here? It's this. Okay, now what are we going to do? What did I tell you the trick as? Whichever exponent is negative and if it is up, just move it down. So we are just bringing k to the power of 1 down. Now when it comes down, the negative sign disappears. As here, see, they disappear when they change the places. So k to the negative 1 power comes down. So that becomes 6k to the power of m. And this is already positive. You don't need to move it up. Positive ones, let it be in the same place. Only the negative ones, move their places opposite so that you will simplify them. So once you simplify, your answer will be like this. Okay, keeping this trick in mind, let's solve this. Now, which is the negative exponent here? The only negative exponent is x to the power of negative 8. Now, x to the power of negative 8, you will move down so that it will become x over 8. But once you move this down, there is nothing up. What are you going to do when nothing is there up? Just write 1. You cannot leave it empty because then it will become a multiplication expression, which is wrong. So when you move the x to the power of negative 8 down, there is nothing left up. So you just write 1. And all the positive ones, you just keep in the same place. This is the only trick you can use rather than doing all those long methods of solving these exponents. Just any negative exponent up, bring it down. Any negative exponent down, just move it up and remove the negative signs once you move them. So that's all for this video. Hopefully you have understood. If not, just rewind and watch it again. Definitely you will understand. Just give some time for yourself and your brain to understand it at once. Don't think I did not understand and don't close the book and keep. Just rewind a bit slowly and then give your mind some time to learn the new things which you're learning. Okay, your mind takes time to learn. It's not that at once you see something you will understand. No, your mind takes time to learn these things. So give some time to yourself as well as your mind and the brain. So just watch it 2 or 3 times. Definitely you will understand. Hopefully this lesson will become easy once you start solving more questions. So keep practicing until we meet next time. Don't forget to subscribe and like the video. Thank you for watching.